All right, we've spent the last two chapters reviewing trig functions, talking about things you learned last year, and also adding a little bit of new stuff. But starting today, we're getting into chapter 11, and that's when we start the stuff that's really new for this class. We're going to take a look at the calculus that goes along with our trig functions, meaning limits and derivatives, and we're going to start with derivatives. So, first thing I want to remind you guys of, this is something I said earlier in the year, a lot of times if you're looking for a shortcut for a derivative, then basically it's just to know what it is. Have it memorized. And remember, we did this when we did our logs and exponentials. So if I say to you guys, what is the derivative of e to the x? You just know it's e to the x. Or if I say, what is the derivative of natural log x? You just know it's 1 over x. Those are things we have memorized. And then the key is to know how to use them. Now that's what we're going to do with our trig functions. So what I'm going to do is I'm going to go ahead and give you the 6 trig derivatives for the notes, and then we'll talk about how to use them. So let's start with these three here. We have the derivative of sine x is cosine x. It's an easy one. We have the derivative of cosine x is negative sine x. Another pretty easy one. Just remember that it comes out negative. And then we have the derivative of tangent x is secant squared x. So I want to make sure that you guys have those three memorized. When it comes to things like the AP calculus test, those are the only three trig functions they put on there. They don't use secant, cosecant, or cotangent on that test. So as long as you have those three memorized, that's good. The other three I'm going to show you, and I'm going to ask you homework questions about, but I don't really need you to memorize it. You can look them up if you need them. So here are the other three. Take a look at that. They're a little bit more complex than the original three. But like I said, we're going to focus on those first three. All right. So one more time for the notes. We want to make sure you guys definitely have the first three memorized. Make sure you know those. Those are the ones you want to know. We're going to add that to our list of memorization derivatives. And then what we're going to do is focus on how to use them. So today we're going to focus on the basic derivative rules, things like product rule, quotient rule, chain rule, things like that, power rule. And we're going to look at some examples now. All right, first example, we have a product rule question. We're finding f prime, and we have f of x equals x times sine of 5x. So that's a product. We have an x, that's our first function, times, and then we have sine of 5x. So if I'm going to do product rule to find f prime of x, let's set it up like this. Kind of set up a place to put our answer in. And remember, when you're doing product rule, it's the derivative of the first function times the second, plus the derivative of the second times the first. We say, okay, well, the first function is just x. That's easy. The second function was sine of 5x. We'll put both of those in. And then when we do derivatives to fill in the last two blanks, one of them is very easy. The first function was x, and the derivative of x is just 1. The other one is the one I want to spend a little extra time on. That's what's new for us today. So I'm going to go down here to the bottom. Now, one of the derivatives we just learned is that the derivative of sine x is cosine x. Now, what we're basically doing is we're doing chain rule on that. We're saying if I want to do the derivative of the sine of anything else, then I'm going to have the cosine of that same angle, but this is the chain rule part. I have to multiply by the derivative of whatever that thing was. So what I'm going to get, the derivative of sine is cosine, so I'm going to have cosine of 5x, but the chain rule says I need to multiply by the derivative of 5x, which is 5. So if I clean this all up a little bit, what I get is just sine of 5x for the first part, plus, and then we will have 5x cosine 5x. So in the front, I just put the 5 and the x together. And I'm going to leave that for my final answer. Sine of 5x plus 5x times cosine of 5x. And that's an example of product rule and chain rule with regards to a trig function. Okay, here's another example. We have g of x equals tangent squared x, and we want to find g prime. Now, first of all, before I start this question, I'm going to rewrite it, because that notation of tangent squared x I want to make sure you guys realize what it means is we're taking tangent x and we're squaring it. And the reason I wrote it that way is because it makes it more obvious that what you're doing here is power rule. Power rule with chain rule. So when I go to find g prime now, I'm going to do the power rule on the 2 around the tangent, meaning I'm going to leave that tangent x where it is, and I'm going to do the power rule around it. I'm going to multiply by 2 and lower that exponent by 1. But then I have to chain rule it. So if it's something other than x that's being raised to a power that I'm doing the power rule on, then I have to multiply by the derivative of that thing. Now the derivative of tangent x is secant squared x. And basically if you just push that all together, that's your answer. There's no simplifying here. You can get rid of the exponent of 1. But your answer ends up being 2 tangent x secant squared x. All right, let's take a look at one more example. All right, so for this one, what we have is our function is y equals tangent x over secant x, and we are asked to find the derivative, y prime. Now this is one of those questions, we've seen a lot of these this year, where there's more than one way to do it, and as it turns out, one of them is actually a lot easier. So I'm going to end up working this one out twice. I'm going to work it out the harder way first, and I actually won't even finish it, but I want to show you guys how much work it could be, and then we'll switch it back and do it the better way. So the harder way, even though it might be the more obvious way, is quotient rule. So if I'm going to do this problem using quotient rule, I'm going to set up this big fraction here, and I'm going to start off by squaring the bottom, secant squared x. And then on the top you have what looks kind of like product rule, but with a minus. So we have the derivative of the top, which would be secant squared x, times the bottom, which is another secant x, minus the derivative of the bottom, which is secant x tangent x, times the top, which is another tangent x. So what we end up with secant cubed x minus secant x times tangent squared x, and the whole thing is over secant squared x. Now this is actually where I'm going to stop. The next step would be to factor out secant x on top, cancel it with one of the secant x's on the bottom. I think we'd have to use Pythagorean identities on that tangent squared x to write it in terms of secant squared x, more simplifying. Eventually we can get to the answer, but you guys can see it's a lot of work. Instead, let me show you the easy way to do it. So what I'm going to do is I'm going to go back to chapter 9, and before I find the derivative, I'm going to use our identities to simplify this. So what I have is tangent x over secant x. Now tangent x is sine x over cosine x, and secant x is 1 over cosine x. And what happens here is, since those denominators are the same, they cancel each other out. This is sine x over 1, or just sine x. And if y equals sine x, then the derivative is cosine x, and it's that simple. So basically, that's our answer. The answer is cosine x, and if you think about what we did on the last slide here, I can't get to the last slide, that's okay. If you think about what we had on the last slide, that was a lot of work. That would have eventually simplified to get the same answer, cosine x. But instead, we did it a much easier way. So that's just a reminder, we've talked about it a lot this year. Remember to always think about if there's an easier way to do a question.